Welcome everyone. My name is Michelle Branzaleski. I'm the marketing manager here at Control Station, and I would like to thank you for your time today for Control Station's public webinar series. Our topic today will be, click the button, there we go. 5 ways to monitor controller variability. Which one is right for you? So with that, I would like to introduce our presenters today. With me, we have the VP of Engineering, Dr. Bob Rice, as well as Brett Beauregard, Director of Product Development. They will be covering the meat and potatoes of this presentation. First, I'm going to do a few housekeeping things, and then we'll get on to the main presentation. Control Station has been in business since 1988, so over 34 years. It was founded at the University of Connecticut. We do have a global footprint of over 70 installations worldwide, and 50% of those installations belong to Fortune 500 manufacturers. Today's agenda, the primary reasons for process control, the 5 ways to monitor it. Then we're going to go through a summary, and at the end we'll take questions and answers. On your toolbar, you will see a questions bar. If you click on Open Pane, it will open up that box. You can type in your questions and we will address them at the end. So the next thing we're going to do is something kind of fun. We're going to do a little poll. I'm going to launch this. You should see it on your screen any minute. You can just take your mouse and click all that apply. What type of method are you using to control variability at your plant? Statistical, performance, automation logs, comparative analysis, or real-time alerts? So I will leave this open a few minutes and everybody can click and I will share the results. In the meantime, I'm going to do a plug for our next webinar, which will be August 22nd. It will be called Innovations in Plant-Wide Monitoring, Diagnostics, Optimization to make sure your plant is reliable. You can sign up on our website, controlstation.com. All right, I will give this about 15 more seconds, and then I'll share this with everyone. Okay, I'm going to close, and I am going to share it on the screen. All right, so Bob and Brett, we got a pretty equal across the board method use. So you guys know which direction to take the presentation. So with that, I'm going to hand it over to Brett Beauregard. Thank you.
Hey, morning, everybody. So I guess we'll kick this thing off by, well, the meat of it anyway, with just talking about why we need process control and why it's important for it to be in tip-top shape. So usually the first reason, or I would say, might be most people kind of forget about the main reason that process control is in place, and that is for safety of the plant and of individuals in the plant. A plant where everything is in manual is not a plant I want to be near by any stretch of the imagination. So we put these automated control systems in place to keep things kind of in safe operating ranges and things like that. But once that system's in place, it's a boon for optimization. So we've got automated control in place, and the reason everybody's so interested in, optimizing it, monitoring it, and all those things is for efficiency, production, all of these things where we can make the control system perform better. We can improve production rate. We can make sure that we don't trip environmental regulations. We can make sure that we don't produce bad product, and obviously economics, right? If you can produce things to spec using less energy, or if you can keep your valve from oscillating or make it move, twice as slow as it was before, mean cycles to failure. All of these things are things that you can gain from a improved process control system, right? So that's why we're really trying to monitor it. And that's really the meat of what we're going to be talking about here is how do we monitor, what are different ways to monitor this control system? And I can see from the polls, you have different ways of doing this. And one of the first ones that we're going to talk about here is statistical modeling. Okay, so using statistical methods to analyze control system performance. So I will pass that to Bob. We'll do a little tag team back and forth on these slides. Bob, what do you what are some ways that we can use statistical methods to analyze process control?
So to me, statistical process control is looking at generally the variance, the variability, the standard deviation, the production of the process as a whole. So if you want to think about it as you're creating widgets or you're creating product, you're creating different things, you are monitoring different statistics about how well those products are created. Are they within spec? Are they within target? Are they within a certain range? And so you use statistics to monitor the overall process behavior of the system, right? And so statistical process control isn't looking at individual PID controllers themselves. You tend to be looking more at the variability or the variance of the process. And that's when you start looking at control charts, XBAR, R charts, and others to start to make sure that the products, the widgets, the things that you're creating are following within a high percentage of positive attributes, right? And so statistical process control is really looking at kind of the bigger picture of a particular area, a particular unit, a particular process to be able to identify that. And you may be looking at, variability of temperature on the output of an oven. You may be looking at the percent of products that are within spec, right? And so you may have different lab or different measurements that you're doing to track the overall process. And so statistical process control is kind of that macro view of a particular area and applying statistics and so forth applied to kind of the bigger picture. When you want to go and look at individual controllers, this is really where you start to get into performance metrics of the individual PID controllers themselves. And so statistical process control is kind of the bigger picture, the macro point of view. I like to think of performance metrics as more of a micro point of view where you're looking at individual controllers and you're looking at the behavior and performance of those controllers, okay? So Brett, what are some of the different KPIs and metrics that you would use on the performance side of the PID controller?
Well, funny you should ask, Bob. As as a director of product development over here, this is really near and dear to my heart. We do a lot of work on finding the right metrics to analyze process control loops. They're all based on similar tags, so like the set point, the mode, the input, the output, but looking at different aspects of those tags and in different ways to help glean finite information about the loop. So it might be something as simple as the average absolute error. How much error does the control loop have? Watching that over time and seeing that maybe degrade can show you that the controller isn't performing as well as it used to. Or accounting, another simple metric would be seeing how often the control loop is in its normal mode. So just it's supposed to be in automatic or cascade. How often is it in automatic and cascade? How often is it not in those modes? These are really important metrics that can help you identify where to look if you have a very large facility with thousands of loops, or even if you have a facility with 100 loops but you don't look at it that often. It's good to know just these simple KPIs can give you a actually very powerful view of your system. That being said, we've also invested a lot of time in going for more advanced KPIs. Again, using the same tags, but looking at the frequency analysis to determine oscillation in the loop, or doing thousands of lines of code to calculate a very reliable stiction metric. So you can say, oh, these are the valves that are sticking. These aren't. Even going so far as to use our advanced modeling capabilities to identify process models to recommend tuning ranges. Oh, your tunings seem to be outside of what we would recommend for a given loop. So all of these things are KPIs. Some of them are standard, some of them are special to control station that we will run, and they're very valuable in terms of winnowing down, and finding the loops that you really want to work on today, or ones that you need to, oh, this loop stiction is 0.5%. That's okay for now, but a month ago it was 0.25, so it's starting to creep up. I should probably keep an eye on that guy because he's going to be a problem soon. So just lots of different ways that you can analyze the same individual tags to get a lot of kind of varied information about the loop. So Bob, the previous thing was, doing kind of a macro statistical thing. Here we're looking at kind of like ground level statistics in terms of identifying tags around a given PID loop to identify performance. But then, as you well know, there's another level that we can take this to, right? We can go down and we can look at the log automation logs from the control system. So can you talk to us about a little bit about that? Are you muted?
So if you talk about the different layers of statistics and performance, you had the statistical process control, which is the macro, and as Brett had mentioned, the performance layer is kind of the micro. Automation logs takes it kind of one depth deeper to try to understand, are the actual inputs and outputs, are the signals, are the bits and pieces of the control loop of the automation system behaving as expected. And so this is where alarms and events and so forth associated with how well the individual inputs and outputs of the DCS are behaving. This becomes really critical as you start to employ things like wireless sensors and so forth to make sure that the health of these systems are coming into the system in a reliable way, right? You don't want to be making control corrections or actions on a signal that is not healthy, right? That is delayed or something along those lines. And so using automation logs kind of takes that kind of performance down to another level, right? Where now you're starting to understand the break and fix side of it, right? Are there unexpected or inconsistent values associated with it? And this can also be down to the layer of using some of the diagnostic information that are in smart instrumentation, right? We've invested a lot of money on smart instruments, and so those create events and logs for us to be able to investigate the performance of individual valves or individual sensors and so forth to make sure the calibration is correct, that the signal coming in is appropriate, that it doesn't need to be, adjusted in any way, and that the signal is correct. Right, and so you've kind of got these different layers associated with the automation system itself, right? And so you've got that macro view of statistics, you've got the micro view of an individual control loop, then you've got the logs and the events and the diagnostic information of the individual systems, right? And when you start to kind of put all of these things together, it allows you to take kind of another step forward and be able to actually do comparative analysis, right? So instead of looking at individual areas, you can start to perhaps expand that search. So Brett, what are some different ways that they can go and analyze site to site, and what are some of the benefits associated with that?
Right, so you can do comparative analysis on even line to line, but also site to site, and get really good comparisons between different areas. So some of this depends on the KPIs that are used. but some KPIs will lend themselves to apples comparisons, whereas others will be more specific. So for example, the average absolute error, for example, will be in engineering units. So you might not necessarily be able to compare one loop to another, but there are others, percent time in normal, normalized variation, KPIs of this type that are much more portable in an apples to apples way. And also these logs and statistical analyses can also be kind of sanitized in a way that makes them generic. And once you have that kind of apples to apples level, you can do some really cool stuff in terms of comparing, again, different areas of the plant if you have multiple lines or multiple business units, but also site to site if you have many sites across the country, across the globe. A plant that in just by looking at it by itself may seem to be behaving perfectly well, may not look so well when compared to another site that's 100 miles away and doing the exact same thing or doing something different. And so what this lets you do is, even if what you're looking at a given site looks good, you can be like, yes, but we can be better because we can maybe copy what this other site is doing or things like that. And so that lets you do maybe like best in class things, rankings of different sites, mostly with the goal of being like, oh, let's see what, there's that site in Albuquerque, New Mexico that's doing great. We should really see what they're doing to maybe copy their performance so that you can take gains from one area and bring them to others. And these comparisons may not necessarily be obvious if you're looking at tons of product produced or things like that, because those might not be apples to apples. But if you can get individual KPIs within sites that are equivalent, that can let you bring performance gains from one area to another. So that's something that's really kind of beneficial in this way. And that's basically the benefit of comparative analysis. You might think you're good, but the guy down the road might be better. Let's see if we can copy what he's doing. So that's really the benefit of comparative. And then the last one we were going to talk about here, I believe, Bob, after comparative analysis, is the idea of using real-time stuff. So a lot of this other stuff that we've been talking about can be done, just as you please, looking at historical data and stuff like that. But there's definitely benefits to doing kind of real-time alerting or kind of notification based on these things that we've been discussing. So maybe you can talk about that, Bob.
Sure, absolutely. The interesting thing about all of the methods that we have discussed so far, statistical performance, automation logs, comparative analysis, it's all monitoring. It's all, identifying opportunities. All those opportunities that are identified are worthless unless there's an alerting and action system put in place to actually go and correct these, right? And so when I think about real-time alerts, what I'm after here is you got to make sure that the alerts that are being triggered are useful and that have actionable information assigned with it, right? An alert for an alert's sake is terrible, right? If you're not going to do anything with that information, why have an alert, right? You can kind of think about it in the same way as alarm rationalization. An alarm without an action, something to correct associated with it, is a worthless alarm. You can think of alerts on performance and production to be the same way. Just telling somebody that the controller's not in normal or that the variability is high without an actual piece of action or a procedure to follow that up is worthless, right? Having 1,000 alerts telling you 1,000 things are wrong without any intervention to do to correct it, it's not going to solve the problem. And so real-time alerts are good, but they have to be done in a measured fashion, right? I'm a very conservative person when it comes to understanding alerts with the system, right? If you've got 1,000 controllers, the last thing you want is to have a list of 500 tasks to do every day. You have to make sure they're prioritized. You have to make sure that they're triggered and set on, specific performance metrics and abnormal behavior that you can actually correct, that you can make something better, right? And so when you're understanding alerts, try to treat them with the same respect as alarms, right? That any alert that gets generated should have an action associated with it, right? It's not just an alert for alert's sake to let me know that, hey, 500 controllers are in the wrong mode today. Great, I'm not going to do anything about it, so that was worthless, right? So make sure that you treat the alerts with that kind of same that same requirement, that there is documentation, there's a procedure, there's an action to take place on those alerts. Make sure there's accountability for those alerts, right? And so there are kind of a whole path here associated with different measures of variability and things to do to correct them, and how to actually, control the variability at your plant, right? We started with that kind of idea of statistical process control, which is letting us know that there is, a kind of a macro view of the KPIs and performance, right? You're tracking the percentage of good quality product, the throughput, the output, the temperatures, whatever your kind of KPIs or your primary control variables are for your system. You're tracking and you're monitoring how well those are behaving with statistical process control, right? Those are giving you your macro view. You then can define the controller performance are the ones that are actually being able to, understand that, right? And so you can actually go and define the individual performance KPIs on the PID loops that impact the individual process control layer, right? So you've got your statistical process control layer, which is giving you your macro view. You then define and decide what are your KPIs on your individual controllers. How do those controllers actually impact your statistical process control? You focus on the KPIs and the metrics that are going to get you better statistical process control, because those are the kind of the final numbers, right? That's telling you your production, your energy consumption, your percent of quality widgets, right? Whatever it is, your statistical process control is kind of that final out the door number. Your individual PID control performance is really about understanding all the individual control loops or the systems that are in your plant that impact the variability of your widgets of your process, right? So you need to make sure you define those in a way that are relevant, right? Again, you don't need every single metric under the sun on every single control loop, because that's probably not going to provide you useful, actionable information. You have to understand what is relevant about a particular controller to understand what impact does that controller have on the bigger picture. So there are a lot of different ways of monitoring that and measuring that variability on an individual control loop basis, right? You really need to make sure you spend the time to decide what is relevant, right? What are the individual KPIs that are there? Again, even the automation logs are going to provide a lot of useful information to help maintenance prioritize the instrumentation that needs investigation, right? You cannot control what you cannot measure. So that automation log is kind of the very bottom of that pyramid of, are your instruments correct? Are you responding to the instrument calibrations correctly? Are you getting the right type of signal? Is it a good signal? Then you're controlling those signals, right, with the performance layer, and then you've got the statistical layer on top of it, right? All three of those things work together to help you do and help you minimize the variability of your plant. Then you can start to take actions. And what those actions are depend on what your goals are, right? So if you're thinking about, hey, I've got 50 plants in my fleet that all produce a very similar product, but each plant is of a different size, you can start using comparative analysis to make sure that all your sites are performing as efficiently as possible, right? So you can start doing comparative analysis to determine best in class, best in fleet, right? To give yourself targets and thresholds to aim towards, right? You can have every plant produce and run, the loops with the same measure of variability. If one site is twice the size of another, comparing throughput is not a fair comparison, right? It's not apples to apples, as Brett had mentioned, right? You want to make sure you define your KPIs in a way that are site to site comparable, right? So maybe it's X percentage of controllers in automatic across the site. Maybe it's in certain areas having a percent of time in normal, or percent of highly critical loops with normalized variance within a specific threshold, right? You can design your metrics, and now you can start to bring your whole fleet up to best in class, right? And as you start to move through this scenario, you're going to find yourself with alerts and actions. And unless there's an ownership and accountability and a flow chart of what do you do once this information comes in? What do you do when a valve needs to be fixed? What do you do when a loop needs to be tuned? What happens when a loop is oscillating, when a valve detects diction, when a loop has high normalized variance? What do you do, right? What is the process? So there needs to be documented SOPs. There needs to be ownership and accountability so that the information out of whatever monitoring and tools that you use out there to track this, that there is a process in place to do it, right? Monitoring without action is not really that valuable, right? Monitoring by itself isn't going to, sustain the benefit, right? The best way to gain benefit is to use the tools, to make sure there's procedures documented in there, right? And you want to make sure you understand all the different ways to measure and monitor that variability, whether it's statistical, performance, and automation, or all three, to make sure that you cover all the bases, you cover all the parts of the pyramid to start to understand where's the variability coming from, how does variability in statistical process control come from variability in the control loops, how does variability in the control loops come from the individual discrete instrumentation that you may have at the automation, and understanding the relationship between those, right? And so it's kind of an interesting polling question at the beginning is which one of these are you using, right? The answer is you should be using all of them, right? They should be all part and taken together to minimize the overall variability of the plant, right? It's not just statistical process control or automation logs. You should be using all of them because they all are designed to work together to allow you to minimize the variability across your entire site, right? So that's kind of the idea behind minimizing variability at your site. It's taking statistical and performance and automation logs, creating a best-in-class series of KPIs, benchmarks, and thresholds, generating your real-time alerts that are actionable, and it becomes part of a life cycle, right? It's not, you don't define the statistical process control at the beginning and never come back to it. It's a loop. You're constantly coming back and trying to understand, okay, what now has changed, right? What are the targets and thresholds that we defined? Are they still relevant? What are the new KPIs or control loops that are impacting statistical process control? What's going on with the automation log? And you're continually trying to maintain this system in a life cycle. This isn't a single action that takes place, you go and deploy it and you're one and done, right? You really have to make sure you treat this as a life cycle, that it's a continuous journey, right? And it's not the destination, it's the journey, right? And the journey, for depending on how you look at it, it never ends, right? We're in a constant state of trying to improve variability. So you constantly trying to minimize your variability, understand the control loops, and it keeps going on and on and on, right? And that life cycle requires bodies, it requires ownership and accountability to make sure that you've got the right tools in place, the right SOPs, the right actions to make sure that you're continually improving the process.
Okay, thanks, Bob. Thanks, Brett. Appreciate that. Now we're going to take some time for questions and answers. We have experts in the field here, so please type your questions in the question box. You will find that box on your toolbar on the right-hand side. Click Open Pane. It will open up and you can type your questions. All right, if we can go to the next slide while people are typing in their questions. Fantastic. If you would like some more information, industry related articles, sign up for one of our training sessions, take out your cell phone and take a snapshot of that QR code. You can go on anytime and register or read anything at your convenience. We do have a question here. Bob, is there any tool you recommend for monitoring?
You broke up there, Michelle. Can you repeat that?
Oh, I'm sorry. Is there any tools you recommend for monitoring control?
Of course, right? So when you are trying to go and monitor the performance of a loop. Control stations got tools called Plant ESP that have LPM, loop performance monitoring, within them to be able to go out and monitor hundreds to thousands of controllers, multi-site, single site. And it's designed to leverage a lot of the data historian that you have in place. So you can install it at a corporate level and hit multiple data servers, whether they're IP21 or Aviva or Wonderware or whatever your data sources are, to pull the data in and start to be able to calculate performance, calculate the variability, more importantly, do comparative analysis, understand site to site, loop to loop, start to generate reports and so forth to be able to hit all the different points of improving the variability of the plant.
Great, thank you. Can you go to the next slide, please? And I'm going to do one more polling question for everyone. You should see it on your screen any minute. Take your mouse and click all that you would be interested in. Please have someone from Control Station provide more information regarding easy-to-use software, turnkey solutions, world-class tuning software, or upcoming virtual training opportunities. I think we have just one. No more questions. I thought someone was typing something in there. So I'll leave this up for a few more minutes. Bob or Brett, is there anything else you would like to add?
I'd like to thank everybody for their time, for sure.
Yes, we know everyone is busy, so we appreciate everyone taking their time today and join us. Oh, we do have a question. Actually, a lot of sensor and actuators are deployed in the industry. So what is the future of the SCADA system?
Well, that's a great question. It's all about information and actionable information. All of the data, historically 30 years ago, 40 years ago, you would just have enough information to run your sites, right? You would have temperatures and you would display that on the SCADA screens. We've gotten a little overloaded on the information on the HMIs, and HMI design and information on HMIs is definitely a whole conversation topic by itself. But the future of SCADA is different levels, right? You've got the information that is needed to run the plant, but now you can start to pull in data into your SCADA on the performance and behavior of your system, right? Not just, hey, am I producing product? It's how well am I producing product? And SCADA systems now are starting to be much more intelligent with being able to bring in data from other sources, right? They're not just designed to look at the control layer and bring up the data. They're starting to interface with lots of different data sources, right? So they can consume data from REST or from other third-party tools, put up there, hey, look, there's performance issues with this. So SCADA can start giving you performance issues. It can start pulling in diagnostic information directly from the instruments. It can start to integrate with MES systems to let you know, hey, there's a valve that's been queued for a maintenance correction next week. And so the SCADA systems really start to be the kind of central warehouse of all the information needed to operate the plant effectively, not just the operator station, right? Just not controlling it. You can really start to bring a lot of this information in. And the SCADA systems are the natural kind of resting point of all that. Everybody, you've already built your plant diagram, your plant system in SCADA. Now you can start to bring all the additional data into your SCADA system. And tools that allow third-party connections in the SCADA are great. Several of our customers take plant ESP KPI data. We have natural REST endpoints on our system. They can consume performance data to display on the SCADA system. Why would you do that? Well, it's one less place they have to go, right? Operators and everybody's already going to SCADA. Why not already have all your performance and diagnostic information directly on the screen where they're already at? Why have another tool that they have to log in and look at over here? And so SCADA systems become kind of that natural repository, and third-party tools that have endpoints for consumption and display are really become integrated into the workflow of the system.
Great, thank you. Any more questions, please type them in. Bob, if you can pull up the next slide. Okay, if you didn't have a question now, great, but you might have one in the future. We have our specialists, North America, Brian and Alessia will take care of you. Our Europe and Middle East, North Africa contacts are Damien and Kat. All right, we don't have any more questions, so let's make it a wrap. And again, I'd like to thank everybody for their time. Next webinar on August 22nd. You can access that on controlstation.com or use the QR code that was a few screens earlier. So thanks, everyone. Thanks, Bob. Thanks, Brett. Great job.
Thanks, everybody. Bye.
Thanks, everyone.